Yeah. Um, okay. Yeah. So hello everybody. Um, uh, this is first, or maybe you can say, a demo class for engineering mathematics class, and myself Akshay, and I'll be taking the mathematics course for this or for next year's GATE exam for various batches. And today, since it's a demo class, we'll briefly discuss about uh, what all things or what all important topics are there in engineering mathematics, at least for the GATE syllabus. And then we'll discuss about a particular topic which is of great importance. So I hope most of you have joined, and then we'll go ahead. So before going to the technical content, uh, uh, I would like to bring your attention to uh, you know, uh, the very important uh, deadline for batch starting for preparation of next year's GATE exam. So if you know your friends or anybody who is still in a dilemma, please you can convince them to join the batches so that they'll be along with everybody else during the course. Yeah, so uh, first of all, a broad outline of the syllabus for mathematics. So yeah. So you can see there are approximately 8 broad themes. There are multiple subtopics under each chapter. For example, if you consider linear algebra, uh, there are various aspects of matrices and their basics as well as their usage to solve numerical, not numerical, sorry, linear solutions, linear system of equations. And then there are various concepts such as vector space, subspace, basis, dimensions, linear independence of vectors. So uh, those things are broadly covered, will be covered under this chapter of linear algebra. In calculus, actually calculus is the biggest or the largest topic. It is, I mean, it will have a lot of topics. It will start from functions, which basically we'll discuss about those today. I mean, some aspects of functions because of limited time. But when we'll actually start the course from next Sunday, you'll see a lot of uh, more discussions on topics in detail. And calculus, it contains a lot of topics. As I said, first it starts with functions, then their limits, continuity, differentiability. There are various theorems to find maxima and minima of a function. Then you come across partial differentiation. There are various differential equations. Some of them are called as ordinary differential equations. Some of them are called as partial differential equations. Then there is a important topic of integrals. So there are multiple integrals also. So basically, integral or integration with respect to one variable and multiple variables. So all those things comes under your calculus. So that is one of the largest topic that we'll cover. Then another important topic is probability and statistics. It is also a very important topic because for certain branches such as ECE, EE, even CS, they their math syllabus is more inclined towards probability and statistics. And nowadays, when it is artificial intelligence, ML, all those courses are offered everywhere. So in that context also, probability and statistics is important. But our focus here will be on the topics which are in the GATE syllabus. So you may not find all the topics related to AIML here, but at least basics will cover here, which is under the GATE syllabus. So in probability, there are certain types of problems, such as there will be cards and probability related to cards, various cards that we play at home also. So then there will be arrangements and selections in linear fashion, in circular fashion, various subtopics there. Then there will be conditional probability based theorem, total probability theorem, etc., etc. All those things will be there. Then there will be various random variables, uh, then their expectation, mean, variance, these typical parameters associated with any random variable will be there. And then we'll cover some topics related to statistics, uh, you know, uh, like linear regression, correlation, regression coefficients, etc. So these first three chapters, they carry a lot of weightage. So typically for engineering mathematics, if you solely consider mathematics question, uh, depending on it varies, because every year, in some years there will be more weightage towards maths, but in some years it will be less. But you'll get 8 to 15 marks from mathematics uh, directly also sometimes. But I feel more than that, uh, this course will form your basis for another courses which are related to your core technical subjects, and that is indirect benefit of studying maths. So direct, though you can understand, you'll get certain direct questions from mathematics, but indirect also there are many benefits. So you should consider that while studying this. So the point that I'm trying to make here is, whenever I teach you some topic, please try to correlate those topics with your other subjects, which are main technical subjects. For example, linear algebra. Uh, it's you can relate it to many subjects, because everywhere we have governing equations in any technical subject, and to solve them, most of the time we linearize them and then use matrix or matrices operations to solve them. So that way you have to look at it. So first three topics are of high importance, and other than that, there are vector calculus, differential equations, numerical methods, Laplace and Fourier transform, and complex variables. These are minor topics, but still they are also important, and we'll cover all of them starting from next Sunday. So moving on. So today, for this demo session, I have decided to take a class and clarify some things about a very important and fundamental concept which is used throughout the calculus chapter, and that is called as functions. So I am sure by now you may have used this term a lot of times, but still, if somebody asks you what is a function, you need to give a mathematical definition, which is not usually taught in proper terms. And by chance, if you appear in any interview and if you say mathematics is my favorite subject or one of the favorite subjects, uh, more or less you should expect these type of questions, because interviewer also knows that you might have studied advanced concepts, but they will catch you or try to catch you in your fundamentals. So uh, towards that end, I thought today we'll discuss some aspects of functions, and that way I will introduce you to various concepts that are associated with functions, and those we will cover in detail in calculus part. So first of all, what is a function? If anybody wants to give an answer or type it out, please do. Yeah. So actually, we have a limited time today, so we cannot wait for long. So we'll go ahead. Uh, So function, you cannot define function directly. First, you have to define a set, a non-empty set, and then between two sets, there will be certain relationships, and then out of those relationships, only a few of them will qualify as functions, and others will be just relationships. So, before going into the definition of functions, I thought we'll discuss something about sets, because this is also a very important or basic concept that is, many a times it is asked in the interviews, etc. So here you can see an image, Venn diagram. Typically in set representation, we use Venn diagrams. So there is a set of complex numbers, which is the largest set of numbers. And then if you remove certain imaginary numbers out of them, you'll get real numbers. And real numbers, there are broadly two categories, something called as irrational numbers, and then there are some numbers called as rational numbers. So essentially, irrational numbers are of the form of fractions. So you cannot express them, as an integer or full, number. They'll be always like fractions. Sorry. They cannot be expressed as fractions. Rational numbers are fractions, p by q, where q is not equal to 0. Whereas irrational numbers, they are not. They cannot be expressed as fractions. Classic example is pi. So you know that it is 22 by 7 and it goes till infinity. I mean, you can expand it up to whatever length of numbers you want. Then out of rational numbers, you have integers. So rational number whose denominator is 1 is called as integer. An integer comprises of negative, positive as well as 0. So then the classification is further there, where you say that whole numbers. The whole numbers is a set of numbers which starts from 1 and goes on the positive side of infinity, but they are integers. And natural numbers, as we all know, it starts from 1 and 2 and it goes to the positive side of integers. And natural numbers are essentially representing that set of numbers which you use for counting. So this is a general idea about sets and like what all number of sets are there. And we will encounter almost all of them during the course. We have a separate chapter of complex variables. There you'll study various things about complex numbers and other numbers, about real numbers. They are involved in every topic, more or less. So coming back to the definition of function. So 1 second. So let's say you have two sets, maybe P and Q, and they will have a number of elements with them. 1 second. Yeah. So let's say you have two sets of numbers, and let's say number of elements in P set is some A, and number of elements in set Q are B. So in this case, there is something called as Cartesian product. So basically what you do, you make pairs of all the elements in one set, that is P, and another set Q. For example, this Cartesian product is defined as P cross Q, and you have PQ. So this is the ordered pair of elements of set P and Q. These are small letters P and Q, such that P belongs to your set P and the Q belongs to your set Q. So this is a definition of Cartesian product, and it essentially means uh, you know you take one element from set P and one element from set Q, and then you make a pair of them, and that is set of all those pairs is called as Cartesian products. So uh, this is the maximum number of uh, pairs that you can form. But in our case, based on, like, there will be certain number of elements in P and Q, but we need to define a relation. Let's say we use a symbol R bar, and that will relate uh, element in P to element in Q. And typically, if you see the terminology, this is the set from which you take the arguments for function or relation. They are called as domain, and the set to which it is mapped, it is called as codomain, and sometimes range also. So there is a difference. There is an important difference also in codomain and range. But this is a typical standard way of representing relations. So yeah, before going forward, the difference between codomain and range is codomain represents all the possible outcomes that a relation or function can have, whereas range is the actual number of outputs that the function has for a given particular set of input parameters. So therefore, range is always a subset of codomain. This is a very famous result, and you should remember this. So in some questions, they try to confuse students with codomain, range, etc., etc. But for all practical purposes, you can assume that whatever we are dealing, we call them as range, because those are the actual outputs that a function or relation gives. So then, there are different set of relations that can be yeah. So between set P and set Q, there are different type of relations that can be defined. The important thing here is you should pay attention to the last two, because first empty relation itself, uh, that empty and universal you can understand, but reflexive, symmetric, and transitive, these are the main or important type of relations. And if any relation satisfies all these three type of relationships or relations, that is called as equivalence relation. Uh, this slide maybe not that of not that important, but I thought you should at least know if somebody asks you what is equivalence relation or what is symmetric relation. Symmetric, though, everybody knows when you swap x and y or a and b. In this case, it is a1 and a2. When you swap them, the function or the relation should remain same. But coming to the main topic that is of our intention, which is functions, because as I said, we will be using these functions, throughout the calculus. So we should at least spend some time on it. So again, we'll take the same concept and we'll try to justify something which is a function, not a relation. So let's say there are 3 elements in set P and 4 elements in set Q. When you define a relation, let's say R bar, but what happens when you define it, this one element in set P, it is not mapped to any element in set Q. So therefore, I mean, if this happens, if any element in your domain is not assigned to any other element in your range, then that is not a function. So this is the classic definition of a function. For a function, every x or every, let's say, typically we use x for domain and range is typically used as y. So if there is any element in x or in set P which is not mapped to any value in set y, then that is not a function. So therefore, the function definition is, in other words, you can say A relation, in this case it is R bar, from set P to Q is said to be function if every element in set P is mapped to a element in Q, and in some cases it is written as it has image in Q, but these are equivalent things. So therefore, basically the idea is not every relationship can be called as function. Only a few of them satisfy function definition, and that is what we are going to use in our calculus class. Then there are various types of functions. So basically, functions is a very broad category, uh, and people try to distinguish them as per the significance. So one of the categories to differentiate function is depending on this category, this classification, which is one-to-one or many-to-one. So as the name suggests, if there are two sets and let's say there are three elements, and each element maps from let's say set T to set Q, but like one element in set P should map only to the one element in Q, and that should be distinct. So that is called as one-to-one or injective. This is also a synonym. I have seen some questions where they directly say that f of x is injective function, and many times if you don't know, then you get confused. And as name suggests, many to one, so that will be something of similar sort, but in this case what will happen, two elements in your domain will map to the single element in your range or codomain. Depends on how strict you want to use those terms. So that is one type of classification. And you know classic example is one second. Yeah. So it's a very famous example. Typically, uh, if you take square function, uh, you know it will map, let's say one element is x and one element is minus x in your range, which is denoted by set P. It will map to a same value in your range. So this is many to one function. So I will request you to uh, you know uh, in your study time, please take commonly known functions and just make sure you know that which is one to one, which is many to one, uh, and that way maybe it will be helpful in your next classes. Then there is there are certain tests which is called as vertical test and horizontal line test. So for example, if you have a function, so till now we were discussing the the function definition in context of sets, but what happens many a times, we have a graph for the function that so for example, let's say you have a certain graph for function which is like this. So let's say this is some f of x, you know so first we'll discuss about vertical line test. So what this test tells you is, if you draw a vertical line and if it intersects your function graph at more than 1 points, so in this case it intersects the function graph at 2 points, and if it intersects at more than 1 point, then this f of x is not a function. And you can relate to it, right? So for example, if you draw the set notation that we discussed, uh, yeah, so what is happening here is at particular x. So basically, to continue in the context what we are discussing, let's say this is your x and y sets. In this case, they contain all the real numbers because we are plotting the function on the xy plane. So what is happening is, let's say this value is x1. So let's say it corresponds to one element in your set P. But for this value of x1, you have two values for y1 and y2. So basically, one element in x1 in x is mapping to two elements in y. So if such thing happens, then it is not a function. So either it should be 1 to 1 or many to 1, but it should not be the other way. One x not map to two y's. If that happens, then it's not a function. That is the vertical test. So if in any question, if they give you graph and ask whether it is a function or a relationship, then you just have to draw a vertical line at any point in the graph. And if that vertical line intersects the graph at more than 1 point, then it is not a function. And that is what a vertical line test is. And then there is a horizontal line test. So this test is used to identify 1 to 1 or one second. Many to 1 functions. We'll take a couple of examples here just to clarify what it means. Let's say you can take one example of let's say y equal to x square, and another example is y equal to x cube. And if you plot them, you know that x square plot looks like this, which is symmetric about y-axis, and for x cube the plot is like this. So this is your y-axis, this is your x-axis, similar here. So now what this test tells you is, if you draw a horizontal line, let's say like this, at any point you can draw a horizontal line. There is no rule about particular point. But in case of x square, it intersects the function graph at 2 points, whereas in case of x cube, it only intersects at 1 point. So the horizontal test says that if there is only 1 point of intersection, then this is 1-to-1 function. And if there are more than 1 points, then this is many-to-1 function. So because most of the times, it is easy to picture any function as its graph. Especially when we'll study the calculus chapter, you'll realize that most of the time it helps if you know the graph of the function. And then you just draw a horizontal line and see. If it intersects the function graph at 2 points, it is many to 1. And if it is only a single point intersection, it is 1-to-1 function. Again, I request you to try another functions such as log, exponential, sinusoidal, trigonometric functions, inverse trigonometric functions. There are a lot of functions, but for GATE exam, this is like the most concentrated set of functions that is repeatedly used. You should at least know them and how to plot them. Then,
Excuse me, sir. Sir, I had a small doubt. Sir,
tell me.
like the square function that you showed, if we like look it from a different perspective, it is also like a vertical line only. If we see the f of y function, so won't f of y be not a function? Because it is also
Pardon?
having two answers. So because it is also having the same values.
So you are saying y equal to x square.
Yes, sir. So f of y
Okay.
won't be a function, but f of x will be, or vice versa.
No, this is f of x only, right? See, this
Yes, sir.
horizontal
This is
line
f
test.
of x.
So this will be function because uh, 1x is pointing to I mean, what am I saying? If you draw like two sets, what is happening here is two x's are pointing to same y. Correct, no? So that is allowed. That is many to one function. But in case of vertical test that we previously saw, if one x points to 2y or maps to 2y, that violates the definition of function. So this is just a correlation. And if you
Yes.
notice, this is a classic equation of parabola.
Hmm.
So if this is the, therefore typically, I mean, this is also very famous question, that whether equation of a parabola which is symmetric about x-axis is a function or not. If it is symmetric about y-axis, it will look like this, y equal to x square, right? Then it is a function. But if it is y square equal to x, or maybe this, like, because this curve is essentially y square equal to x, so this is not a function. So basically, you have to remember, if 1x maps to 2y, that is not acceptable, as a definition of function is violated. But if 2x points to or maps to one single y, that is acceptable. That is actually the definition of many to one function.
Yes, sir. So f of y won't be a function then.
What is f of y? Uh, you are saying, because typically we consider y as the independent variable and x as the dependent variable. So when you say
Correct,
f
sir.
of y, then you are making the independent variable as your dependent variable. So that
Hmm.
thing we do when we define inverse or something like that. But at this point we are not. So don't get
Okay, sir.
confused. Just take x as your dependent variable and y as independent one. Sorry, x as
Okay, sir.
independent, y as,
Hmm. Y is okay, sir.
okay. So we'll move next. Yeah, then there is another classification. This is also, at least you should know these terms. That's why I'm introducing them. So onto versus into. These onto functions are also called as surjective functions. And so in terms of set theory, uh, again we'll go back to our same notation that we are using for the sake of consistency. So in some functions, what happens? Let's say there are entries like this. What happens? You'll have, let's say this is a many to one function, and two values of x map to one value of y in q. But what happens? There are certain elements in set q which don't have any you know any image or pre-image in your domain. So if such thing happens, then this is your this function is not onto function. Basically, this is equivalent to saying this is into function. And uh, if you want to define onto functions, so essentially it means whatever, let's say same notations if we follow, it means that all elements in your set q, which denotes the range, all elements should be mapped by some element in x, or your domain. This is your domain, this is your range. So it should happen that all the elements in your range or y values, they should have certain image in x. And if this happens, this is your onto function. These are just definitions, but in some questions they directly mention that this is f of x is into function, f of x is onto function, or many a times they'll just say that f of x is surjective function. And if you don't know, then you're stuck, because in maths uh, there are, in some cases there are no options. If you know, you know. If you don't, then you don't know. So that's why it's essential you should know all these terms. And there is one more thing, I think, which is called as, you know bijective function. This also term sometimes is used. So this is nothing but a function which is injective. That means it is one-to-one function, as well as it is surjective function. That means it is on-to function. That means all elements in your range, that is all y values, are mapped or pre-mapped with all x values, or x values, not all, like that. Because if all x values are not mapped, then it's not function. So by definition, it is incorporated. So I would suggest don't focus too much on memorizing these terms, but at least when you are revising, because you have to revise a number of times for this exam, but at least you should know these terms so that you will not get bogged down when you see such unknown term. And as an exercise, if you are if you want to check whether you have understood these concepts or not, it's always good to solve some questions. So I'll give you a homework question. Maybe you should solve this on your own. First is verify f of x equal to 3x squared plus 5 is bijective. So here you need to first check whether it's one-to-one function, and then check whether it's on-to function. If it is one-to-one as well as on-to function, then only it is bijective. If one of the condition is not satisfied, then it is not bijective function. So I know the answer, and maybe if you have listened to me properly, you also know the answer. But just go through it, and just for the sake of one more function that I can give is, let's say, e to the power x into sin x. So maybe you should solve these two questions, and let me know in the next class if you have any doubts. But the discussion that we had so far, you should be able to solve these questions, is what I feel. Then yeah, this is the most important classification for functions as far as our course is concerned, because we will use this extensively in integration topic. Because if you know the nature of function, whether it's odd or even, there are certain tricks in your integration methods, and it simplifies many a times. So by definition, an odd function means if you put f of let's say, one second. For odd function, it means if you put minus x in place of x in your definition, and if it returns minus f of x, then it is odd function. For example, let's say I define a function as sin x, and if I replace x with minus x, then what happens? F of minus x is sin of minus x, and we know that it is equal to minus sin x by definition of sin, and that is minus f of x. So sin x is a very famous odd function, and there are other odd functions also. You can take it as a homework and find out which commonly known functions are odd, because that helps in many cases. One of them is during integration. And even function is when you put minus x and still you get f of x as the output. So again, a famous even function is cos x. So what happens if you put f of minus x? This becomes cos of minus x, and which is equal to cos x by definition, and that is equal to f of x. So cos x is a very famous even function. So you should at least remember the definition of these till we discuss calculus part, and it is helpful there. And in the meantime, you can check out another function such as e to the power x, exponential function, log x. Are these functions odd or even, or neither of them, because not all functions are odd and even. There are a large category of functions which are neither odd, neither even. So that is also to be looked at. And one more thing is, we will discuss this later in details, but you should know that uh, you know there are something called as composite functions. So maybe we'll not spend more time here on this, but you should know. So let's say there is one function which is defined as y equal to f of x, and then there is another function which is defined as y equal to g of x. I can define one function which will be f of g of x or g of f of x, and these sort of functions are called as composite functions. Uh, in this case, you should pay attention to their domain and range. So what happens uh, when you change the argument? So here basically x was your independent variable and y was your dependent variable. But if when you make a composite functions, this g of x becomes your argument or independent variable. Then you have to check what is the uh, possible values that g of x can take, and that is your domain for this composite function. So you have to the reason why I'm mentioning composite functions here, we'll discuss them later, but you should always pay attention to their domains and codomains or range, because those things change when you make a composite function. So you should pay attention to that, is the whole point. Then this is a very famous tree diagram which highlights another classification of functions, and where you classify them as algebraic and transcendental. Transcendental functions, they become important in your numerical methods topic, because there are no analytical solutions to integrate these functions, or no closed form solutions are there. So you have to take help of numerical methods, and that is very you'll see when we'll discuss numerical methods, you'll see that most of the time when you have transcendental function, you cannot directly integrate it using the standard rules, and you then shift to the trapezoidal rule or Simpson's rule, and etc. Whereas polynomials, as you may know, x square plus 2x plus 1 is a second degree polynomial, like that. And yeah, there are certain class of functions, and one of them is very important, which is modulus. Typically it is represented with a straight bracket, and there are many questions in GATE exam or many other competitive exams typically with this modulus functions only. We'll take some problems after this, but you should carefully study this modulus function and solve as many as problems you can solve for this, because there is very high likely very high possibility that at least one question you can expect from mod, maybe not directly from maths, maybe somewhere else, but it's not far-fetched possibility. Then there is a sine function which is also called as signum function, which is nothing but a composite function of modulus and a simple x, y equal to x, and this function gives sine of your function. So it only takes value between -1 and 1, and at x equal to 0 it is 0. So that is the signum function. Greatest integer function, again it is also called. So I'll go to the page. Greatest integer function, or I think before that we should discuss mod, because that's important. Modulus is, or maybe and its plot is like this. Sorry. So this is your origin 0, 0, x-axis, y-axis, and you can see modulus. It will always have positive y values greater than 0 or equal to 0. We'll take certain problems. 1 second. We are running out of time, but 1 second. Or otherwise, what we'll do, we'll discuss theory and we'll solve problems together. That is easy or better way. And yeah, the other one is a step function, which is also called as greatest integer function. And the reason why it is called a step function is because its graph looks like a step function. And what I mean by that is, if you plot it, let's say this is 1, 2, -1, 0. What happens is it is defined in such a way that between 0 to 1 it will take value of 0 and there will be a discontinuity at 1, and again at 1 between 1 to 2 it will take value which will be 1, and again it will jump. So similarly between -1 to 0 it will take value of -1, and then again it is jumping. So there is something called as discontinuity in a function. We'll discuss that in calculus class, but for the time being, you can imagine the function is defined in this way. Typically it is denoted by square brackets, and for the sake of understanding, between -2 to -1 it will be taking value of -2. Between -1 and 0, with 0 excluded, it is -1. From 0 to 1 it will take 0. So you understand, right? Wherever it is in that between two integers, it will take the value of the smallest one, and at the highest end it will jump. So that is why it is called a step function. And like that, it is defined for from -infinity to +infinity. And here, just for the sake of argument, I am showing it like this.
Yeah, hi Aksh. You didn't ask them any question, they didn't respond at all. So, guys, any doubt, anything?
Yeah, actually,
No, sir.
I asked one question, but nobody responded. So I thought maybe we'll take the questions at the end.
So, all of you are understanding, guys?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Yeah, thank you, guys. Okay. Fine, then please continue. Yeah, thank you.
Yeah, if you have any questions, you can ask me, or you
Or
can.
at least you can ask Akshay to respond in chat box. Whatever you ask, they
Yeah, yeah.
understood yes or no. That you
Okay.
keep asking. Yeah, please.
Okay. So yeah, then this topic we'll not discuss today because we are running out of time. But definitely we'll take it up in the calculus class, because in exams you'll not get straightforward question, because everybody knows how to plot y equal to mod x or step of x. So what they will do, they will try to change it. For example, you can see some questions in which they will give you function which is summation of two mods, and it is mod x minus 1 plus mod x minus 2. So what is here done is they have shifted the function with the constant by a constant amount. So there are certain function transformations that are possible, uh, using which you can either shift the function upward or downward. Left to right is also possible, and you can multiply with the constant, and if that constant is greater than 1, that is called as stretching the function or enlarging the function. And if the multiplying constant is less than 1, but if it is between 0 to 1, then it compresses the function. So the graph of function will be compressed in the y direction. And then there are certain transformations such as taking mod of the x or taking mod of the whole function. In that case, there are mirror. It results in the mirror imaging of the function about x and y axis. And there is a very helpful online resource. This is called as Desmos graphing calculator. This is a free website where you can plot how many functions you want, and it will give you directly the plot of the function. I find this website very useful because many a times the things become clear with the graph, and therefore I will advise you to use this graphing calculator, which is a free resource, and at least plot let's say e to the power x, e to the power minus x, log x, log x into e to the power x, and many combinations you can do. For example, sin x into cos x. You can play around, and you should get familiarized, because when we'll discuss calculus, by the time if you are able to use this resource, it will be pretty much easy for you. Uh, you can play around. It's a free multiple usage site. I personally use it, and I found it very helpful. So then these are like typical aspects of functions that you should know. And the reason why I took this topic up today for a demo session is because functions, we all know, we know everything about functions, but still mathematics is such a topic where there is no end to it. So hopefully you have taken some positives out of this, and now we'll solve some questions. We'll discuss functions again in our calculus lectures, so don't worry if you have any doubts or anything you did not understand, and maybe you realize it that you have some questions, you can ask me later also, no issues. But since we have now some 10-15 minutes, we'll take some questions, and so that the concept become clear, because at the end of the day you have to solve questions, otherwise theory will not take you that much ahead. So yeah, we talked about composite functions, right? So we'll take one question. So let's say these are all previous year gate questions. So you can understand and you can appreciate these type of questions have been asked, and maybe in some other form they can be asked again also. So they have given two functions which are g of x and h of x, and they are defined as g of x is 1 minus x, h of x is x by x minus 1. Then g of h of x divided by h of g of x. This is the question, and you have four options. Okay, so these four options are there. So now maybe I'll use another color. So here, as I said, when you do the composite functions, your h of x now has become the input to your g function. So therefore, what is your g of h of x? It is nothing but 1 minus h of x, because g of x is defined as 1 minus x. And now instead of x, h of x is the input to your g function. So therefore, your g of h of x becomes 1 minus h of x. And similarly, h of g of x becomes g of x into g of x divided by g of x minus 1. I hope this is clear because this is the most important step. If you have any doubt, please ask. I'll wait for a couple of seconds, or you can type it out also, no issue. Yeah. So now in question, they are asking the ratio of these two functions. So basically what they are asking is 1 minus h of x, 1 minus h of x divided by, what is the g of h of x is? G of x divided by g of x minus 1. This is what they are asking, right? So now the question is, we don't see any option which is similar to this, right? So we need to simplify further. Now what is the definition of h of x? Go back to the question. It is x divided by x minus 1. So we'll put all those things here. So this will be x divided by x minus 1 in the numerator, and g of x is defined as 1 minus x. So you'll have 1 minus x divided by 1 minus x minus 1 in the numerator. Okay. So now we can further simplify. So you'll have x minus 1 minus x divided by x minus 1 in the numerator, and at the denominator you have 1 minus x as it remains same, and you'll have minus x because 1 gets cancelled. Now you can simplify because you have minus 1 by x minus 1 at the numerator, and we'll reverse the denominator so that it becomes multiplying factor. So this is just a simple simplification, because as you can see, x and x will get cancelled, so you'll have only minus 1 at the numerator, minus 1 by x minus 1, and the denominator is 1 minus x minus x. So if you see, this is x divided by x minus 1 into 1 by 1 minus x. Okay, I'm just rearranging the terms, nothing fancy here. And if you see, this is nothing but x by x minus 1 is nothing but h of x. The first term becomes h of x, and second term is 1 by g of x. So 1 by g of x. So basically this is h of x by g of x, and that is your option first, option 1. Okay, so like this you have to deal with composite functions. You should solve more questions about composite functions, because I've seen many students get confused in this type of questions. We'll take one more question which is also interesting. So the question is, they have defined the function, but the definition is slightly tricky. So what they have mentioned is a function which is represented by symbol f maps n plus to n plus. Now this is a new thing, and they have mentioned what is n. N plus is set of positive natural numbers. And if you remember, at the starting of this class we discussed various set of numbers. Set of positive natural numbers is nothing but whole numbers. They could have just mentioned that x and y take whole numbers, but just to confuse students, they put it as n plus or something like that. And f of n is defined as, it has two definitions for, it is f of n by 2 if n is even. Maybe I should have 1 second. So f of n by 2 if n is even, but if n is odd, then is defined as f of n plus 5 if n is odd. So the f of n doesn't have a single definition in this case. It is having, depending on n value, whether it is odd or even, it takes two forms. So that is the trick in this problem. And it is asked that the maximum number of distinct values that f of n can take are. And it was a data entry question. There were no options, it's just a data entry question. So like that. So this looks slightly tedious problem, but for such problems you should, and for another, like many problems in GATE exam, the trick is, I'll write it again here so that it is easy. For n even, and it is n plus 5 for n odd. Okay, this is our definition. So you can see, and it is a positive natural number. So f of 1 is the first value. So n is odd in this case. So f of 1 will be equal to f of 1 plus 5. That will be equal to f of 6, right? Because that is the definition. But now you can see f of 6, if you consider 6 is a even number. So therefore it will be equal to f of 6 by 2. So that is equal to f of 3. Now f of 3 is, if you consider, what happens here? F of 3, f of 3, the 3 number is odd. So therefore it will be equal to 3 plus 5. So that will be equal to f of 8. But f of 8 has n which is even. So this will be equal to 8 by 2, 4. 4 is also even, so 4 by 2, 2. 2 is also even, so you have to divide it by 1, and therefore it will be equal to f of 1. Okay, so now you see all these quantities are same because everything is equal to f of 1. We started with f of 1. So 1, 2, 3, 4, 6, 8. So essentially what we observed is f of 1 is equal to 2, is equal to 3, is equal to 4, is equal to f of 6, is equal to f of 8. Okay, and we have just used the definition of function. But now what is remaining? Now 5 is remaining, so let's consider 5. Maybe we'll use a different color here. So if you put f of 5, 5 is an odd number, so that will become equal to f of 10. Or maybe I should write it as 5 plus 5. That is the definition, second definition of function for odd n values. That is equal to f of 10. But now f of 10, 10 is even number, so that will be equal to f of 5 because 10 by 2 is 5. So here you notice that, from here you notice that f of 5 and f of 10 are same. Okay. Now what is remaining? 1, 2, 3, 4, 5, 6, 7 is remaining, 9 is remaining, and higher than 10 values. So now we'll check f of 7. Oh, I'm sorry. So f of 7, 7 is odd number, so you have to add 5 to it. So this will be equal to 12. this will be equal to 6, this will be equal to 3, this will be equal to f of 8, and so on, because we already did this once, right? It will be 4, 2, and 1. So essentially, it may be slightly confusing, but you know, what we are getting is this is also equal to f of 7. If you have any doubts, please ask me, because this is slightly
Sir,
difficult to
hello,
answer.
sir.
Yeah, tell
Am I
me.
audible?
Yeah, tell me.
Am I audible?
Yes, tell me.
Sir, I have a doubt, sir. Sir, how can you mention that the if function of 8 equals to f4 equals to f2 and the f1? Sir, that part I can't understand. And another one is when I have the found the f of the n plus 5, when n equals to 5, then it comes the f of 10, then equals to 5.
Mhm.
Sir, that part I can't understand, sir.
Okay,
What
okay.
is the main function, sir?
Okay, okay. Uh, okay. So, 1 second. Yeah, so the definition is n by 2 for even n values, and it is f of n plus 5 for odd n values, right? So when you have f of 8, 8 is an even number, right? So that will be equal to 8 by 2, which is 8 by 2 is 4. Now 4 is also even number, so you have to divide it by 2, because you have to use the first definition, right, for even numbers. Therefore it becomes 2. Now 2 is also even number, so you have to divide it by 2, then you get 1. And again from 1 you'll start, because 1 is odd number, so you'll have to add 5 to it, and this will become f of 1 plus 5, right? That will be f of 6, and we
Yes, sir.
already did. So we already started from f of 1, and we got this again, total 3 line of f, and we finally got that f
Oh,
of 1,
now
2.
I understand, sir. Thank you, sir.
Hello?
Now I understand, sir. I understand.
Yeah, understood, no?
Yes, sir. I already understood, sir.
Yeah.
Thank you, sir.
So basically, now only f of 9 is remaining, because 1, 2, 3, 4, 5, 6, 7, 8, and 10 we already did. So let's go back to 9. Let's say we start with f of 9. What happens here? So f of 9, it is an odd number, and then you have to add 5 to it, so that will be f of 14. 14 is an even number, so you have to divide it by 2. That is equal to f of 7. And if you go back one page, 1 second. So we already know that f of 7 is equal to 1, 2, 3, 4, 5, 6, 8. And now we observe that 7 is also equal to 9. F of 7 is also equal to f of 9. So that means, this is also equal to f of 9. So now you can check, if you can take f of 11 and see, but it will essentially come back to the, because what will happen, f of 11, see, because it is defined for n, n goes to infinity, right? So we started with 1, we checked everything between 1 to 10, but you can argue that we have to check for 11, 12, 13 also, right? But it will essentially boil down to what we already know. So for example, if we have f of 11, 11 is odd number, so you have to add 5 to it. 11 plus 5 will be 16. Then again it becomes equal to f of 8, because 16 by 2, 16 is even number, so you have to divide it by 2, so f of 8. So because it is defined in such a way that whatever number you take, if it is multiple of 5, then only it will be having a distinct value. For example, okay, here only I can say, for example, if I take f of 15, then 15 is a odd number, so I have to add 6 to it. So 15 plus 6, that will be 21. That is also odd number. then I have to add 6 to it. 1 second. Yeah, f of 21. Then 6, if you add, it is f of 27. And then if you
But
add...
f of 15, why not 5 added?
Oh, sorry. sorry. It is, you have to add 5. I could not see the definition. Sorry, my bad. So it will be f of 20 because you have to add 5, not 7. Then again, it will become equal to f of 10 and f of 5. So what I'm trying to say is, if n is multiple of, if n is multiple of 5, then it will have certain value which will be f of 5. And if n is not multiple of 5, it will only have value which will be equal to f of 1. And therefore, there are only two distinct values that f of n can take for all set of positive integers or positive natural numbers. So the answer is 2. It was a data entry question. So the answer is 2. I'm not writing it here because if anybody is seeing it later, they should not get the answer. So, but I request you, maybe I did it slightly fast because of the time pressure, but I request you to go back again and just look into the solution or try to solve yourself, and then you'll realize that only two values are possible for this function. Then
Excuse me, sir. Sir,
Yes, tell me.
sir, sorry, sir. I haven't understood that there are only two distinct values. That how can we get only two distinct values, sir?
Yeah. So what is happening here is, if you take n as a multiple of 5,
Yes, sir.
because see, the trick is here only, because the definition of n, definition of function, you can see
Yes, sir.
n plus 5. So
Yes, sir.
if n is multiple
Yeah,
of
first
5,
time we got. Yeah.
so if n is multiple of 5, basically you are making it an even number by adding 5, and then
Yes, sir.
it will, if you divide the multiple of 5, it will again it will come back to the multiple of 5 only. For example, if I take n as 5, add 5 to it, it becomes 10. And then again, if I divide it by 2, it is still multiple of 5 only, no? So
Yeah,
therefore,
yes, sir. Yes, sir.
yeah. So that is why multiple of 5 will take distinct values, whereas non-multiple of 5s, such as 1, 2, 3, 4, or 6, 7, 8, 9, they will take same values because of the definition like that. You can see on this page that we have reduced that. You started
Yes,
from
sir.
f of 1, and you all the way you get back to the f of 1. And only 7 and 9 were missing from this series, so we studied them separately, and we realized that if you take f of 7 separately, you again come back to the f of 1.
Yes, sir.
Okay.
Sir, here we have when we have take f of 5, then again we got f of 10 equal to f of 5, no, sir?
Yes. So
Sir,
that means,
again in the last, yeah, yes, sir. Again in the last slide, when we are doing f of 15, again we got the same f of 10 equal to f of 5, sir.
yes.
Yeah, so then
Yeah.
if n is a multiple of 5, then means for that case we have written two distinct values, sir.
No. If n is multiple of 5, it will
Then
eventually
we are
come back.
not getting F1. What Kiran it is,
There will
if
get
you have, if n is multiple of 5, you are getting F5. If n is other than that, you are getting F1.
Okay, sir.
Yeah. Yes,
Okay, sir. Means anything other than f of 5, we are doing we are getting other f of 1. Okay, sir. Understood, sir.
Yeah, you can take one homework if you are not convinced. You
Thank
can
you, sir.
solve for f of 17 and you can see what value you get. You will eventually get f of 1. Maybe you can take it as a homework and solve for f of
Sir,
17
what
because
homework you can give? You can ask them F11 to F20, so they will realize.
yeah, you can do that. If f11 to f20 you solve and you let me know in the next class what all values do you get for each one of them.
So for F15 and F20, you will get F5, remaining all F1. That should be the case.
Yeah. That is the correct answer and you should get that.
So any doubt, guys? Any concern? How was class today? It was different from conventional math class, right?
Yes,
Sir,
sir.
Yeah,
actually, hello, sir. Sir, I actually joined in the hub station, sir. After the hub class, I joined, sir.
No problem, Arpan. That's fine. It was a demo class just to, you know, tell you guys how we deal a subject, right?
Yes, sir.
And mathematics is one subject which should be interesting, okay, to all. So when we
Sir,
start first class, be on time, and yeah.
sir, hello,
Yes,
sir.
Arpan.
Sir,
Yeah, tell Arpan.
today which topic we have discussed?